if you're trying to understand a system, a complex system that's probably got loads of nonlinear, recurrent feedbacks going through internally and externally, like a living creature, or a stand-in for a living creature. As an observer, you're interested in the behaviour as described at a sort of high-level, gross level of the behaviour. Is it intelligent? Is it doing the right things to ensure its survival? So, quite a lot of artificial life, quite a lot of what I've been involved in is what's the relationship between the high-level descriptions, behavioural-level descriptions of complex systems like this, and what's the low-level mechanisms that can allow the high-level behaviour to work. So, the left-hand assumption, next, the neat assumption is, if this high-level behaviour can be described by coherent high-level rules, that must be because down in the mechanism, down in the computer code, that's why the computer metaphor is so convenient, there is low-level stuff specifying that these are the rules to be followed. In contrast, next, the Scruffy approach, as I want to reinterpret it, is to say, hey, that's not going to happen. There's not going to be neat low-level mechanisms replicating the high-level stuff. It's going to be really complex stuff. It may be an opaque black box. The neat Scruffy guy is much happier, as I am, with opaqueness. But what you're interested in is setting up a system with holistic attractors manner, an ad hoc design, and you welcome noise, and the word immersion, I put in scare quotes because I don't like the word at all, but that's the sort of word that people often use. And this different mindset leads to building mechanisms in a totally different fashion. Next. So that covers neats and scruffies very briefly and shortly. I have holograms in the title of the talk because holograms are, for me at any rate, a really important metaphor or example of the core of the Scruffy mindset, at least as I want to reinterpret it. Next. Now, nowadays you get actually holograms on your credit cards and things which are flat and work in white light, and they've sacrificed the fact that they work in white light for other limitations. But the classic hologram needs a coherent laser and produces a coherent laser coming in from the top left, split into half of it goes to the object, half is reflected around as a reference beam, and your photographic plate picks up the interference pattern. So you've taken a photo of that object with some interference pattern actually in the emulsion of the photographic plate. And next, you can then use that photographic plate for observers to see the object as a 3D virtual object behind the photographic plate, the reconstruction beam and the reconstructed wavefronts, and the viewers off here. Next. And this leads to interesting properties. So there's a hologram of a Statue of Liberty. It's probably not the real Statue of Liberty. I mean, that's probably a hologram of a model Statue of Liberty. And here's a mock-up of the photographic plate, and here are the viewers. And when they look through the photographic plate, you see the virtual image behind. And normally with photographs, when there's modules, different parts of the image, the torch, top left, is normally the top left of the photographic plate. Not so at all with holograms. with a hologram, you can look through any part of the photographic plate and see the whole image. So you could actually cut out that corner, or indeed any other small part, put it up in front of yourself, peer through at the right angle, and there it all is up there. And if you make it the bit you cut out small enough, it starts degrading a bit, but basically the whole of the image is provided at any part of the photographic plate. So that fits the way that I defined scruffies, who look at the high-level behaviour of a system. So here's a system that these three people will look through and they will all agree that there's a Statue of Liberty. And if you ask them to point where are the torches, they'll all point, and their three arms will meet at some virtual point behind the photographic plate where the virtual torch is. If you as a scientific observer go around and peer behind the plate, there's nothing there. But they're agreed. So it's a virtual object, and this is to my mind, emblematic of how mental objects appear. There is objectivity is subjective agreement between the audience. They will all point in the same direction, so in that sense there objectively is something there. Next. Okay, so holograms are a good metaphor for all sorts of scruffy, artificial life-like approaches to studying complex systems, because the image is distributed, which leads to graceful degradation. Information resides relationally in invariance of the dynamics and behaviour, not in symbols. Where is the torch? Well, there's no bit of code or whatever on the plate saying, here is the torch. And I'll try and illustrate this with two examples where the holographic metaphor has been crucial. Next. So the first is an anecdote from Mexico in 1966. Next. And this is my oldest friend Jeff, who's the son of a Stalinist entomologist who collected pythons and mongooses. And I've known him since the age of 7, that's him at about the age of 7. And next, we were at school together. I'm the handsome one on top left, he's the ugly one sitting in the front. And next, between school and university, we went on a sort of gap year to Mexico, where he has family in Mexico. That's Jeff and me and George's cousin, who's now a famous Mexican botanist. And we had lots of adventures, and just naive 18-year-olds, and lost our passports and had all our money stolen, and all sorts of exciting things. And during that extended period, we had lots of conversations about the world and philosophy, and I had been really influenced by cybernetics, and had built, with a different school friend, one of Grey Walter's turtles out of motorcycle parts. And I was being influenced by this hologram metaphor as a metaphor for the brain, for how memory works in the brain. And I persuaded Jeff that this was an exciting new way to think about the brain. And he got excited. And this did have consequences, because this is Jeff Hinton, the godfather of deep learning. And this hologram metaphor set him off on that path. He's a bit slow, but he's very, very determined. And 50 odd years later, he's got it to work, roughly speaking. Next. And it is based on this scruffy approach to looking at high-level invariants that arise from the invariant properties of complex systems in a non-intuitive way. Next. And next. At a totally different end of the scale, I gave a talk yesterday on wave navigation in the Pacific, traditional ways of navigating boats in the Pacific, based on patterns in the waves. So people can sail without instruments from one island to another, but maybe 7 days to sail, based primarily on the wave patterns. How do they pick up what's going on? So I won't recapitulate what I said yesterday, except that those who went to the talk